Algebra 2, Chapter 6 Review. Don't forget to turn in your review packet on the day of your test. So first thing I would like to show you all the answers that I've written down. And this time I'm going to give a grade on your review. So make sure try all these questions and practice them. And here's your answer for your page number 1. So take a look, check on the answers. Number 1, number 2 are adding, and subtracting. So for number 1, don't forget when you subtract polynomials, whatever given at the second one, everything inside gets subtracted. So basically you can treat the minus as like multiplying -1 to every term in the second parenthesis. So -1 times +4, -1 times +1, -1 times -8. Again, when you subtract, everything in the second parenthesis gets subtracted. So number 1 and number 2 are addition and subtractions. Number 3, multiplications. If you don't see any operations between parentheses, it's multiplications. So multiply, and I like to put them in the orders so that it's easier for me to collect like terms. Number 4, x minus 2 raised to the third power. So that means I have to multiply x minus 2 3 times. X minus 2 is multiply itself 3 times. So check on your answers. Number 5, long divisions. So you have 2 questions there. Set it up. Take your dividend, divide by the divisor. The highest degree of your dividend has to be eliminated each step of the way. So make sure in long division we use subtractions. We subtract along each step to reduce the highest degree of your dividends. And if there are any missing terms, you can see for the second one, 4x cubed plus 6x squared minus 5, I put an emphasis on the missing term of linear term, 0 times x. Don't forget to put a 0 to hold your spot. And when you write your answers, write in the format of dividend divided by the divisor equals your quotient plus remainder over divisors. So again, dividend over divisor equals quotient plus remainder over divisors. Divide using synthetic divisions. We practice this quite a bit. Synthetic division is all about taking out the coefficients from each terms, and if there are missing terms, so again, if you take a 6, question number 6, the second one, you see I put an emphasis on the missing term for the quadratic. Make sure you put on a 0 to hold the spot. So for dividing synthetic divisions, drop down the leading coefficient as your first step and then multiply your quotient. So your quotient is the number below your division sign. Multiply that with the divisors. And divisor would have to be in a linear equation in order for you to do the synthetic division. The divisor has to be in the form x subtract x minus. So x minus is part of the information required, and whatever it is subtracting. So for example, the first one is x minus 2. 2 is being subtracted, so 2 is our divisor. The second one, x plus 3, you will have to change it into x minus -3. Notice that I wrote it on the upper right corner of x plus 3 turn into x minus -3. X minus -3. So -3, x subtract -3. -3 is the number of your divisor. Number 7, so use synthetic division. Basically, the remainder is going to be the information as if you're plugging in the numbers. So the remainder, so you notice that I put the remainder to represent the final answers. So for number 7, g of 3 equals 72. G of -2 equals -48. So again, check on your answers. Make sure you practice each of them. This time you will need to turn in your review packet with everything filled. So that's for your page number 1. Page number 2. So I'll give you some time to check on the answers. Number 8, 9, 10 is asking you to solve by factorings. So think about the method we discussed about solving the polynomials. So in this chapter, we discuss higher degree polynomials, and we introduce the concept of factor by grouping, as if you see in question number 8. Factor by grouping means I am grouping it by 2 terms each, and then factor out the greatest common factors. Number 9 is like the fake quadratic. It's a polynomial raised to the 4th power, but we can actually use the factoring fish method we discussed in chapter 5b to factor this particular polynomials, which is being raised to 4th power. X raised to the 4th power, I can consider it as x to the 2nd power times x to the 2nd power, and then I factor from there. Number 10 is the method we discussed about common factors. So as you can see, x is the common factors of all 3 terms. After you factor the common factor x, you have x times x squared plus 5x minus plus 6. So x squared plus 5x plus 6 is the regular quadratic equations, which we can factor into x plus 3, x plus 2, and then from there you can solve for your x values. Number 11, 12, 13 are writing polynomials with the given zeros. So this was on our last day of the lessons. When you are given the polynomials, you are asked to write when you are given the zeros, you are asked to write the polynomials. I'll use the simple formula of x minus the given zeros, x minus the given zeros, x minus the given zeros. So for number 11, I have 3, -2, 4. So 3, -2, and 4 are given zeros. So I write it as x minus 3, x minus -2, x minus 4. Number 12, x minus 1, x minus -2, x minus 2, x minus -1. Number 13, you have double root, so I have to subtract 1 twice. X minus 1 times x minus 1 times x minus 3. Number 14, find all the roots using the rational root theorem. So rational root theorem says that you have to take the factors of your constant over the factors of your leading coefficients. Factors of your constants over the factors of your leading coefficients are your possible roots, are your possible zeros. From there, you have to try and check with the synthetic divisions. So take a look and check your answers. Don't forget, for this type of questions, do not forget to plug it in zeros if there are any missing terms. As you are seeing in question number 15, we are missing the quadratic x to the 2nd power, so put a 0 there. Number 16 and 17. So graph the following. So I'm using the concept of zeros. So identify the 0 first. So some of you like to use the term opposite, x minus 2, x plus 1, x plus 3. So the zeros are 2, -1, and -3. Mark this down. How about the y-intercept? Y-intercept is always by plugging in x equals 0. So for this case, I have positive 6. X equals 0, y is 6. With all that information put on the graph, and then I'm going to calculate a few points in between zeros and 1 point below the zeros and 1 point above the zeros. And these are the values, so check on your answers. Number 17, use the same concept, and don't forget x squared. X squared means you have 2 zeros at x equal to zeros. So it's kind of repetitive, the zeros, zeros, zeros. So which 0 means which one? It simply means that x equals zeros make the function equal to 0. Y has a value of zeros. And this number 17, it's an even degree polynomial. So the shape looks like a W. The shape of the graph looks like a W. Again, check on your answers, practice your problems. Graph the following. So number 18, 19, 20, 21 uses the same concept we discussed, finding the x-intercept first, and then for your graph to be more accurate, make sure you plug it in a few points in between your zeros and 1 point below your zeros and 1 point above. So try your questions and make sure you plug it in. You can either use the synthetic substitution synthetic substitution to calculate your values, or you simply plug it in the numbers. So for example, like number 18, I wrote x equal to -1. You plug it in -1 to calculate the y output to turn out to be 6. You plug it in -3, the y output turns out to be -20. You plug it in 3, y turns out to be +10. So once again, make sure you practice all this. The number you plug it in, the more points you plug it in, the more accurate your graph will look like. And again, I'll give you a few minutes to check on your answers. Do your practice. Ask me any questions you may have on the day before your chapter test. The last page of your chapter 6 review. So first I would like you to take a moment and look at the answers I provided here. These are basically going backwards. I give you the graph. Can you write out the functions? So do you think you can do that? I don't think we have mentioned specifically of writing out the equations in our lessons. So I would like to use this opportunity to quickly go over these informations. And you will find it's very similar to what we discussed in the writing out the equations with the given zeros. Writing out the equations with the given zero, which was on the last day of our lessons. So take a look at number 20. First thing, I would like you to identify the zeros. So reading out from your graph, do you see that x equal to -2, x equal to +1, x equal to +3? These are our zeros. So we can directly plug it into the functions of the formulas of x minus the zeros, x minus the zeros, x minus the zeros. Since there are 3 zeros that we identified, so I'm going to write it as x minus -2 times x minus 1 times x minus 3. Is that the whole equations? Are we going to be correct just by writing out the zeros? Well, there's one point that you can check, which is very obvious, the y-intercept. The y-intercept should be very obvious and easy to read. So for this case, we have y-intercept located at 0, 6. 0, 6. As we plug it in, 0 plus 2, I have 2. 0 minus -1, that's -1. So 2 times -1, that's -2. And in the last parentheses, 0 minus 3, which is -3. -2 times -3, that's +6. So it matches up with the y-intercept point. So basically, it tells us we have the correct equation written. So using the y-intercept point should provide you with the information of your last piece. If there's an A, the vertical stretch or compression factors or reflections. Number 21. Number 21. So for this particular case, again, the y-intercept we have -3, -1, +1, with a -1 as double roots. And then you can check your y-intercept point. And I think I have written this equation wrong, so I'm going to cross it out here. The equation should be f of x equals negative. Why do I have to put it in negative? Because it's reflection down. So x minus +3, x plus 1. -1 is a double root, so I have to put on x plus 1 squared. And then in particular, number 22, the graph, the function crosses the x at -2, but the shape is not like going over it smoothly. So I'm assuming it's going to be a triple root there. It's going to be a triple root there. And one last time, you will have to verify it using the y-intercept point, which is 0, -8. Number 23, we have a -2 as our double roots, -1 as single roots, and +1 as double roots, with the y-intercept point located at -8, 0. So again, check on your answers, practice these problems, and ask me any question you might have on the day before your chapter test. Don't forget to turn in this review packet on your chapter test day.